this is Honors Algebra 2 Pre-Calculus. We're doing 6.5 from the Pre-Calc textbook, which is the trigonometric form of complex numbers. So recall that complex numbers can be written as, we'll use z for complex number, but it could be r or q or pick anything, but it doesn't matter. We're going to use z here. Z equals a plus bi, where a represents the real component, meaning the part that only includes real numbers, and I represents the imaginary component. So either A or B could be 0, right? What makes it a complex number is that it has both real and imaginary parts, but it's possible to have just like 0 plus 5i, in which case the real component is 0, or 2 plus 0i, in which case the imaginary component is 0, right? So complex numbers is a big subset of numbers, right? And within those numbers, you can have numbers that only have real components, because that would mean that b is 0, or you could have numbers that only have imaginary components, which would mean a is 0. So when we graph those way back when, which we did in Algebra 2, remember that the x-axis is our real axis when we graph imaginary numbers, and the y-axis is our imaginary axis. So, for example, if I wanted to represent z equals a plus bi, I would go to a on the x-axis, which is my real axis when we graph complex numbers, and I would go to b on my imaginary axis, and I'd have a comma b, right? So, there's a bunch of different ways that we can sort of walk through how to write this thing in complex form, but I think if we picture that what we're really essentially looking at is like a triangle here, right? This is a right triangle with a theta here, and we know that this side, since this measurement vertically is b and this measurement horizontally is a, that essentially I'm looking at a triangle. So if I were to call this side z, right, because this is the entire number, right, this number z, I could actually figure out most of the stuff that I need to figure out about how to write this thing in complex form just using my knowledge of SOHCAHTOA and Pythagorean theorem. So rather than just give you this formula, I'm going to walk you through a couple of things and how they make logical sense. The first thing we're going to walk through is the definition of what it means to be the absolute value of this a plus bi, right? So the absolute value of a plus bi is essentially the hypotenuse of this triangle, right? So it's the square root of a squared plus b squared, right? Which would give you the hypotenuse of this triangle. So to be clear, it would give you that z, right? It would give you just that hypotenuse, right? Whatever. And actually, if we don't want to call it z because z was the complex number, let's go one step further and let's call it r like we would call it if we were in polar, which eventually you're going to learn to deal with. So let's just call it r. So, again, if I wanted the absolute value of my complex number, I essentially do the square root of a squared plus b squared. So we're going to do a quick little example 8 with absolute values, and then what we'll do is after we're done with that, we'll do another video where we start talking about this trig form of complex numbers. So example, oh, sorry, it's not example 8 because we're in 6.5. It's example 1. Example 8 would have been if we were still in 6.4. So for example, actually, let me give myself some space. So, for example 1 in 6.5, let's say that I give you some z equals 3 minus 2i, right? First thing we're going to do is we're going to plot on the axes, right? And the second thing I want us to do is I want us to find the absolute value of z, right? So if I were to plot this on the axes, remember my real axis is essentially my x, so I'm looking at an x coordinate of 3, and my imaginary axis is my y, so I'm looking at a y of negative 3. Well, a positive x and a negative y puts me in quadrant 4. So 1, 2, 3, 1, 2, that point's going to go right there, right? So this is 3 minus 2i, because it's the point 3 comma negative 2, right? Because this is my real axis, and this is my imaginary axis. For lack of a willingness to write out the word imaginary, we'll write imag. So that's what it looks like, and if I want the absolute value of z, right, it's going to be the square root of a 3 squared plus a negative 2 squared, which should give me a root 13. So that's how we'd find that absolute value. It's interesting because what I want you to notice is it's not an accident that that absolute value is definitely the length of this hypotenuse, right? If I draw in the triangle, it's not an accident that the hypotenuse is a root 13, and we're going to talk about why that's significant in the next video.